The purpose of this video is to show you an amazing tool that is the Ideality Principle to solve a set of algebraic linear equations without the need of using Gauss Elimination. I set out to talk about this principle because of its general applicability and its effectiveness in dealing with problems of different nature. Consider the following set of 5 algebraic linear equations given at the American Invitational Mathematics examination in 1986. How would you solve it? The first idea involves using elimination schemes taught normally in a linear algebra like Gauss Elimination or Gauss-Jordan. How are we sure that this approach is convenient? Gauss Elimination, which requires this total number of flops floating point operations, consists of 2 stages, a forward elimination and a backward substitution. In the first stage, we have to triangularize the system of equations and eliminate all the unknowns located below pivots in order to determine the 5th unknown. In the second stage, instead, we will identify the remaining 4 unknowns by back-substituting previously found unknowns. However, this method is unnecessarily unwieldy for solving the set of 5 linear equations. Therefore, how might we solve it more quickly? Ideality solution probably represent one of those principles that can transversely be applied to merely every problem. To solve the above set of 5 linear equations using the ideality principle, you have to basically inspect the equations and try to depict in your mind how it looks like the ideal final result. Just ask, what would ideally help me solve this problem? Then identify a specific problem, and finally just use mathematical manipulation or theorems to solve the specific problem. As we can see, the equations only differ from one another in the position of coefficient 2. This quickly suggests that ideally it would be desirable to have an equation of this type with k integer, in that we could use it to eliminate 4 unknowns and leave only 1. Therefore, the specific problem would be how might we obtain this equation? To obtain the desired equation, just sum up each equation on the left. This produces the following result, which turns in this final equation. Now, subtracting this equation from each equation within the set on the left, we easily obtain the final solution. How do we do to know if this is the correct solution? We simply replace the obtained values in the original system of linear equations and check it out that this system becomes an identity if you do not want to experience painful outcomes during an examination or more in general in your career. Now, try to solve the same problem using Gauss elimination and see how long it takes to determine these 5 unknowns. Here the takeaway is, ideality, also known as ideal final result, helps us easily identify a direction search to follow, especially in complex situations. It should be the first approach to use whenever you want to solve a problem. First, you have to idealize the solution and thereafter figure out which concepts and which theorems you might use while proceeding backwards. We will be talking more about this and other powerful principles in future videos. Also, try to figure out whether or not you are making a progress toward a goal by estimating beforehand.